Welcome to the TB2J tutorial. In this video we are going to learn how to compute the exchange parameter with Siesta from the very beginning. We will use BCC iron as an example and only collinear calculation. That is to say, only the isotropic exchange will be calculated. First, we have to prepare the input file and the pseudopotential file for Siesta. Let's have a look into the input file because we already have it here. Basically, what we need is to do a CF calculation in a primitive cell. And the only thing to notice is perhaps we need to save the Hamiltonian and overlap matrix, which can be tuned on by the SCHS parameter. So let's have a look at the parameters. We have the system label Siesta, so the output files, we have the prefix Siesta, and we have the mixing parameters. The spin is collinear, and we have the exchange coordination functional, which is PBE, and the mesh cutoff, the species, and the basis set, and the structure. You can see that it's a primitive cell, so we have only one iron out there, and the initial spin and the key points. Then we can run Siesta. Okay, so the Siesta calculation is finished. We can see that the spin moment is 2.3, which we will use later. Let's have a look at the output files. So we can see that we have this siesta.hsx file, which contains the Hamiltonian and the overlap matrix. If your Siesta is compiled with the netcdf library, we will also have the siesta.nc file, which also contains the Hamiltonian and the overlap matrix. We could have a look with this command ncdump siesta.nc, and we could find the Hamiltonian here and the overlap matrix. Now with this we could use the Siesta2J.py command and specify the FDF file name, which is iron fe.fdf, and the magnetic element iron and the key mesh. And that's it. Okay, now the calculation is finished. We can have a look at the result, which is in the TB2J results directory. We have this .out file, which contains all the exchange parameters. We can see that first we have the cell parameters and the positions of the atoms and the magnetic moment, which is 2.3, which is the same as in the DFT result. And we can check the exchange parameters. We have the first neighbor, which is 19, and the second neighbor 12, and third neighbor minus 2.6, and so on and so forth. There's another file called jvsr.pdf, which is the exchange interaction via the distance. We can have a look. So it gives an overview of the distribution of J, the first neighbor, second neighbor, third neighbor, and so on. Okay, so you can see that the calculation is really simple. You only have to turn on the saving Hamiltonian and overlap matrix in the input file and use a simple TB2J command siesta2j.py and give it the input file name of the DFT calculation and the elements and the key mesh And that's all then you get the exchange parameters. Thanks for watching this video and see you next time.